Let's find a solution to this interesting question. We're asked to show using algebra that for every n in the set of natural numbers, n+1 raised to the power of 3 minus n to the power of 3 is not a multiple of 3. If this is a multiple of 3, it must be divisible by 3, right? So now let us expand it. Let me start by expanding n+1 raised to the power of 3, which is the same thing as n+1 raised to the power of 2, then also multiply by n+1. If you expand n+1 to the power of 3, it will be n squared plus 2n plus 1. Then we're going to multiply it by n+1. This n here multiplied by n squared will be n to the power of 3. N times 2n will be 2n squared. Then n times 1 is n. Then we use 1 to distribute as well. Plus 1 times n squared is n squared plus 2n plus 1. Let's simplify this, collect the like terms. We have n to the power of 3 plus 3n squared, 3n squared plus 3n again, 3n, then plus 1. But remember, we have minus n to the power of 3. So we're going to take n plus 1 raised to the power of 3, then minus n to the power of 3. You know that this is the expanded form of this, so let's replace it. We have n to the power of 3 plus 3n to the power of 2 plus 3n plus 1, then minus n to the power of 3. N to the power of 3 will cancel n to the power of 3. What do we have left? We have 3n squared plus 3n plus 1. Is this divisible by 3? First of all, let us factor out 3 here because 3 is a factor of 3. So this is 3 multiplied by n squared plus n, then plus 1. We can clearly see that this is not divisible by 3 because if you try to divide it, this is not divisible by 3 without remainder. But suppose this is 3 or any other multiple of 3, we can conclude that the whole of the expression is divisible by 3. So if you divide 3n squared plus n plus 1 by 3, you're going to obtain n squared plus n, then plus 1 divided by 3. And 1 divided by 3 is a fraction, right? Meaning it is not divisible directly without remainder. And hence we conclude that n plus 1 raised to the power of 3 plus n or minus n to the power of 3 is not a multiple of 3. It's not a multiple of 3. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.